Recorded, it's rolling. It's Wednesday, May 6th. We're going to continue this final exam study guide uh, uh, back where we left off. Right. So I have three Kahoots. We did the first Kahoot the other day. We're doing the second part today, and then we'll do part 3 later. I do have a few Module 11 makeup quizzes, so some of those are out. You guys are making that up. Have to make that up. Guys, also, don't forget this. Your 90% pi goal is due in 2 weeks. 2 weeks. And the last time we checked it, we're up to 16% now. 16% of students have achieved that. All right, so, all right, you guys are ready on Kahoot? Yep. All right. Okay, yeah, you can still hop in. All right, and here we go.
Oh yeah, I will down. Whoa.
Here, guys. Actually, I forgot. I was gonna set this up for. I'll tell you what the answer is. Let's read this. The half-life of carbon-14 is 5,730 years. What's the value of K? And you guys see this expression out here? You see this little K? Okay. So that an archaeologist could carbon date an organic artifact. Okay. Here, guys. I'll tell you all what the answer is, but more importantly, later on, I'll show you how to solve it. I'm gonna flip the screen in a minute. You guys see this red answer right here? See the right answer? Right. Yeah. Sorry, I meant to set this up and have you guys solve it before I even started this Kahoot. Okay. But that's the answer. So everybody knows the answer is the right answer? Okay. All right. Now, more importantly, how do you set that up and solve it? All right, so let's flip over here. Okay. And you guys be taking notes here because we're giving all these answers. Looks like we are on, well, yeah, we're on 17. There you go, 17. Right. You guys see all of this whole list of logarithm rules. Right, so this will be printed on the final exam. You just have to know how to apply it. So I gave you guys this formula: A equals A naught times e to the kt. Right, that's what I gave you. Right, so this could be exponential growth or exponential decay. If power is negative, which this one will be, it'll be exponential decay. So if you have a like living organic material, there's some concentration of carbon-14. As soon as something dies, I'm just telling you the science of how this works, then that proportion of carbon-14 decreases. And if you can measure and quantify how much carbon-14 there is, then you can back calculate how old it is, T. Okay? But to be able to use this formula to do that, first we got to solve for this K right here. Okay, this K. Okay. Right, now, do you guys see the phrase half-life? Half-life of 5,730 years. Okay, no, this is specific to carbon-14. Right, other radioactive materials could have different half-lives. Right, but carbon-14. Okay, now what that means is that if I plug in 5,730 years for time, how much do I have compared to how much I started with? I'm pointing to the answer.
Oh, half.
Half. Right. So it doesn't matter what you make up for the original amount, A naught. You always end up with half of that. So I have half of the original amount if I started with the original amount, but I allow exactly 5,730 years to pass. Yes, yet? Is it? Right. Now, if it helped, you could make up a number for A naught. Like guys, if I made A naught 100, I'm going to end up with 50 because 50 is half of 100. If I started with 32, I'll end up with 16 because 16 is half of 32. Okay? But at the end of the day, it doesn't matter what you make up for A naught because you always end up with half of that. So it's really the proportion that matters. You see it? If A was 100, and then you have half of 100 is 50. Okay. Okay. Now it's time to maybe be applying these logarithm rules so I can solve for K, which is otherwise stuck in the exponent. You guys see that too? Okay. So here's the critical step. What do you apply to both sides? How do you undo e to the power of?
Log.
Natural log. Yeah, you guys remember this natural log key right here? Okay. In fact, that's specifically for the space of e, which is exactly what we have. Okay. So guys, let's take the natural log of both sides. I'll say natural log of the left side equals natural log of the right side. So with that. So I have natural log of 1/2 equals natural log of e to the k times 5730 years. Right there. Right. And then, because of properties of logarithms, starting to get to this last review, right, is that this power I can bring down in front. I can say natural log of 1/2 equals k times 5,730 years times natural log of e. But I bet a lot of you guys know what natural log of e is. Guess what is natural log of e?
Is that one?
It is. It is 1. Or you may have just jumped straight from here to here anyway and said, oh, well, natural log of e to the something is that something. That's all you have left over. Okay. Therefore, k is equal to natural log of 1/2 divided by 5,730 years. They're leaving off this data, but these are years. Okay. So let's try this. Let's do natural log of 1/2 and then divide by 5,730 years. Okay, and that will give me k as a decimal. It is negative 0.0000121, and that's 1/years. Hey, isn't that exactly what I told you guys to choose on the Kahoot? Is that right? And now you remember how do you get that? Okay. While you're finishing write that down, I'll draw you guys a little graph to the side what this could look like. So if I want to know what's the amount of carbon-14 as a function of time, and I start off with some initial amount, this is what this exponential decay curve looks like. Looks approximately like this. Okay, so every time period you have every 5,730 years you get half of what you had in the previous time interval. So it's half. So okay.
So it's 1, 2, 2 of this here, and 1, 3, 1.
One.
It's for C.
Oh, CD. Okay. You have to do the whole across the row and down the column. Okay, so you guys got K? Right, you guys know how to find K? Right? Right. You know, well, I got my screen flipped. Right. Yeah, I meant to set that up before I even get going with Kahoot. But you guys know that K for carbon-14. You guys know that? Okay. Now the very next question is really just an extension question. Okay. Exact same scenario, carbon-14, same how right. Now you know the value of K. Are you guys ready to calculate how old is? Yeah, that's the actual application. What's the approximate age? Guys, approximate age, you're really solving for what? Yeah, time, which is still in the exponent. So I think it's going to be a very similar process. But now you know K. Okay? All right. So I'm going to flip over to the Kahoot question, but you guys know exactly what's coming up. So there's your K value. Okay. And what if we found an old artifact that has 75% of its original carbon-14? This route there. Yeah, it's common. Yeah, here, take the pass. All right. So you guys had to set some solid. So we're starting from this formula, A equals A naught, e to the KT. You know what K is, so you can plug that in to answer the last question. Whatever that. Okay. And the premise here is that however much carbon-14 you started with, now this artifact only has 75% of what it should have, or what it did at the beginning. Okay. So you get 75% of A naught equals A naught, A naught cancels out. Right? And the important fact so far, the important detail is the 75% of that, like that ratio. Okay. Now, what we're solving for at this moment is stuck in the exponent. So how do you get it out of the exponent? You have to apply a what?
Natural log.
Yeah, natural log. So let's take natural log of left side equals natural log of the right side. And that will simply leave you with that exponent. Right? Could that be the case? Okay. Then there's just one more step. Can I just divide down the coefficient? Okay. Plug that in the calculator. So we get, it should tell me the age of this artifact. All right. So that's what I'm seeing on my calculator screen. Okay. Now, realistically, can you know down to the year exactly how old? Not really. It gets a little fuzzy. Okay. So I may have rounded this to 2,380 or possibly even 2,400 years. Right, but this should be one answer that's very close to your calculator number. Yeah. Missing a little precision. Okay. All right. You guys got that in your notes? You guys got that?
Yep.
All right. Yeah, there it is. 2,380 years. 2,380 years. Yeah. All right. Let's check this out. So I gave you guys this right here. Um, since what you're solving for is stuck in the exponent, do the same thing you did for our last question. You take the logarithm. Actually, yeah, let's do natural logarithm because I do have the base e. So that's nice. So left side just turns into x minus 7. And we've got natural log 95. So let's do x equals 7 plus natural log of 95. Okay. So what do you got there? What 7 plus natural log 95? Looking at 11.55. You guys got that in your notes? Yep. Yep. All right. Very good. Let's check this out. So I gave you natural log of x plus 5 is all equal to 2. Okay. So how do you undo a natural log? Well, you can do e to the power of 2 equals x plus 5, or you can do e to the power of both sides. That cancels out the log of. Okay. There's a couple ways to think of that. But no matter how you think of it, this should be one of your steps. And then I simply subtract 5 over, and I get that number, which is about 2.39. Right. You guys know natural log is log base e. Also, for all these, if you wanted to, could you take your answer and plug it back into the original statement? Okay, here, I'll do that. Oh, you guys are sorry. Yeah. What if I do natural log of 2.39 plus 5? Now, this is rounded a little bit. But this should come out very, very, very close to 2. It is. It's 2.000 something. Okay. So if you take the answer and plug it back into the original statement, should confirm that. Multiply. All right, secure. Oops. So here's what I gave you. Right, we got all these fractions all multiplied together. Okay. What I would start thinking is, I wonder if I could factor any of these more complicated looking ones. Like, for example, this top left term, the 2x minus 18. Could I just pull a 2 out and make it 2 times x minus 9? Okay. Okay. And usually what happens with these types of setups, what's happening right here is that some of these terms are now going to cancel, like this x minus 9 bit, this x minus 9. And I'm allowed to do that because this is all multiplied together. Like if this was added, I would not be allowed to, but it's multiplied, so I can do it. And how about this polynomial looking expression over here? I can factor that too. It factors as x plus 5, x plus 3. And so once you factor so many of these, it kind of goes back to algebra 1. I can check my work by foiling backwards. So x times x is x squared. Bing. Outside, inside. 3x and 5x is 8x. Bing. And then last, 5 times 3 is 15. Bing. So yeah, that definitely factors like that. Okay. And now that factors like that, and look at this x plus 3 bit and this x plus 3 bit, that's going to cancel. Okay. So this and this is the same. I just copy pasted that and then cancel those bits there, cancel those bits there. And all I'm left with is the 2 times and then the x plus 5, which was the answer. Now, if you want to, you could distribute the 2 and make it 2x plus 10. That's the same thing. So you guys can factor and cancel. Remind you guys, of course, on the final exam, you'll have one that looks exactly like that, except some of the numbers will be changed. So maybe it factors a little bit differently, but look for things to cancel out, right? If you factor it correctly. If you have trouble factoring this, then a good tip too is to say, well, this is probably going to cancel out with something in the denominator. So it's probably going to be one of the factors. Right? And it definitely is. This x plus 3 cancels with the x plus 3. Okay. If you're still stuck, you can play up multiple choice answers because there's only so many answers correct. You could bring in quadratic, and that could help you factor it. There's a few ways. Very similar question. Ooh. All right, let's go back here. Before I flip the screen over, here is if you see a fraction divided by a fraction, the very first thing I would do is I would take this bottom fraction and do what with it?
Like flip it and then multiply.
Exactly. Flip and multiply. Flip and multiply. So I'm going to take this whole bottom fraction, I'm going to flip it and multiply it. Okay. And that is what this looks like right here. So I definitely flipped and multiplied. You see it? Oh, and at this point, does this just turn into the previous question? Yeah, pretty much. Yeah. Right. I say, okay, well, what can I factor and what's going to cancel? Yeah. Right. And I can start to spot around looking for some hints. Like I do see an x plus 5 here. Do you guys think there's probably going to be an x plus 5 factor, this whole polynomial looking one in the top right?
Yeah.
Probably so. So I'm going to guess that it is. And I start with an x plus 5 and say, okay, well, what would multiply to give me negative 15? Well, that would have to be negative 3, wouldn't it? So it's probably the other factor. And then I start checking my work. X and x is x squared. Bing. Negative 3x plus 5x? Well, that's 2x. Bing. And of course, 5 times negative 3 is negative 15. Bing. Yeah, it definitely factors like that. Right? Furthermore, in the denominator, I can pull a 4 out, make it 4 times, and then x minus 3. Yeah. Now, from this line to this line, I just copy and pasted it so I can do a bunch of canceling. So this x plus 5 definitely cancels. I suspected from the beginning that was probably going to be the case, and it turned out it was. Okay. But furthermore, look at this. This x minus 3. That cancels too. Yeah. And all I'm left with is a 12 here and a 4 down here. So 12 over 4, which reduces to 3. That's the answer. 3. Okay. What that 3 means is that 3 is not what x is equal to. You never actually solve for x. X could be anything. You could, for example, you could plug in pi for x. You could up your calculator. Here, maybe I'll do that while you guys are finishing writing that down. Okay. I'm going to type in this original expression up here at the top. But I'm going to everywhere I see an x, I'm just going to plug in a pi. And watch what crazy thing comes out as. 12 divided by, let's write, pi plus 5. Okay. And then multiplied, multiplied. I got a pi squared plus 2 pi minus 15 divided by, and then 4 pi minus 12. Right. Guys, I plugged in a crazy number for x. I plugged in pi. It's irrational. But guess what I'm going to get out of all that? 3. Oh, look at that. It is 3. Hey, maybe that's another way you could do this too on the final exam. If you get totally stuck. Right. Right. I mean, if all the answers happen to be numerical answers, looks like I set this one up to be like that. Okay. It's a little trick too, right? Hey, you guys good on that one? Okay. All right. Add and simplify.
That's you. Wait, what did you do? So, asshole on this. It's over to them. It wasn't there.
All right, let's check this out. Check this out. Alright, so if I ignore the pinking here, that's what I originally gave you guys, right? Guys, to add fractions together like that, you have to have a common what? Denominator. And guys, what will the common denominator be?
X plus 6.
It will be. Yeah, it'll be x plus 6 times x. It will be. Okay. So over here, guys, what am I covering up with my left hand? Whatever what?
X over X.
Exactly, x over x, which of course is equal to 1. That's why you're allowed to do that. And it will give me exactly the denominator I want. What am I covering up with my right hand?
X plus 6 over
X plus 6 over X plus 6.
Aha! Exactly. Okay. So same theory, right? Same theory. Okay. So now I will have a common denominator of x plus x. So set that in place. And I can make one giant fraction here. I got a 4x, so there's my 4x. I got a 5x here, and a 5 times 6 is 30 here. Okay. Last step, combine like terms. 4x and 5x gives me 9x. Now, this is the answer that it had as an answer for, so you can do that. Okay. If you wanted to go an extra step, yeah, you could factor a 3 out of here. It looks like out of the top, but that was the answer to this. So remember, if you're adding together weird looking fractions, you have to have a common denominator to add fractions together. And you guys know how to get common denominator? That's good. That's good.
Yes, sir.
All right. Common denominator. Which equation describes the following graph? Here, I'll help you guys out. Guys, you can get this from the vertical asymptotes. Do you guys see a vertical asymptote here at 5? These are number 5, 10. You guys see at 5, x equals 5. And also at, it looks like -7, right? So I do not want to divide by 0. I cannot divide by 0. So I think, where would it be? I think it's this green one I can get from the denominator. See, like if x was 5, he would be dividing by 0. Or if x was -7, he would also be dividing by 0. That's what makes me think it has to be the green one. Okay. Now, there's some other clues too. Like I see a horizontal asymptote at y equals 0. That's also consistent because I have x over x squared. Right. So yeah, for a number of reasons, I think the answer has to be that green one. Yeah, you see it? Okay. Here, let me go back to the graph. Okay. What else could you say? Guys, could you play around with the intercepts? That could be a hint too. Like I do see it has a small negative intercept. It's at approximately 0, -1, approximately. Okay. So if I were to plug in 0 for x, I should get a approximately -1 for y. Okay. I think that would also be the case with the green one. Okay. So there could be many hints that would lead to the answer, right? But probably the most obvious hint, I think, would be those vertical asymptotes. I see a vertical asymptote at x equals 5 and a vertical asymptote at x equals -7. Okay. So remember, you're not allowed to divide by 0. That's what would lead to those vertical asymptotes. Hence, the answer has to be that green one. Okay, so you guys good with how to spot a graph? Okay. Yeah. Okay. Determine the oblique asymptote. Do you guys remember doing long division? It's time to break out some long division. Long division. Let's do some long division. All right. So yeah, remember, guys, whenever you see oblique asymptote or slant asymptote, you have to break out some long division. I'll go through step by step. So here's the numerator inside this box, and here's the denominator outside. Okay? So here, guys, look up here. I'm giving you guys all the answers. All you have to do is take some notes. Coming up. Okay. Guys, how many times does x go into x squared? X times. X times. Because what is x times x? X squared.
Yeah.
Now, don't forget this -2, because what is x times -2? -2x. Right? Then you subtract going down. So x squared minus x squared is 0. 5x minus -2x. Careful, don't trip over the negatives. I might distribute the negative. It ends up being plus 7x. Okay. Then you drop down this plus 9. Okay. Next step. Guys, how many times does x go into 7x? 7 times. So I do plus 7. By the way, you have the answer at this point. Okay. But just to finish it off, 7 times x is 7x. 7 times -2 is -14. Subtract going down. I get 23. So if I were to finish the long division, it would be plus 23 over x minus 2. But that's irrelevant to the slant asymptote. The slant asymptote is this bit right here. It's just y equals x plus 7. That's the answer. Right. Furthermore, I was able to type this into Desmos while you guys were still writing. Right. So, whoops, wrong scroll. There we go. Here we go. Right. So, do you guys see that red equation right there? Is the equation straight from the Kahoot? Right. And this blue equation is what I'm claiming is the answer, the oblique asymptote. And look at that. Look at that. That definitely is the slant asymptote, isn't it? See, it fits snug right in there. That's what a slant asymptote is. An oblique asymptote. That's it. Right. So you guys get oblique asymptote? Oh. Yeah. Here you
Yeah. Because I didn't know when it's
Because it's 9 minus negative 14, which is 9 plus 14.
Oh, okay.
Yeah.
I forgot.
Okay. Which creates the yes, this little remainder bit that doesn't actually affect the answer though.
Okay.
Because the idea, well, yeah, it's like if you let x go to like 1,000, what would this asymptotically approach? And this
Oh.
little remainder bit would go to 0 eventually. Okay. All right. Whoops. No. Hang on. Just minus stuff. All right. Next one. Determine the y-intercept. Y-intercept. Ooh, guys, can you just plug in 0 for x? Isn't that what y-intercept is? Let's plug in 0 for x. 0, 0. Hey, is that 9 over negative 2? If you let all the x terms go to 0, you just have 9 over negative 2. What is 9 divided by negative 2? Get the answer. Everybody see the answer?
Oh my gosh.
So if you plug in 0 for x,
I see it.
you get negative 9 over 2 for y.
Yep.
That's the y-intercept.
Exactly.
Y-intercept is just wherever is x equal to 0, what is y equal to? All right, you guys got that?
Yes, sir.
Right.
Well, that's
Right, here. Go back and, right. So whenever I ask y-intercept, just plug in 0 for x. This goes to 0, this goes to 0, this goes to 0. All you have is 9 over negative 2. So the coordinate is 0, comma, negative 9 over 2. Ooh, number line represents the solution to this inequality. Got it. X plus 1 times x minus 3 is strictly less than 0. All right. Yeah, probably could have had a little more time to the clock on that one. Okay. So here's the setup. Okay. I made a number line here, just a single axis, x-axis. And if I'm comparing to 0, then what would zero out this whole thing? Because that would be some special tipping points. Like, for example, if x was negative 1, wouldn't that make this bit 0? Or if x was positive 3, that could also be 0. Okay. So I'm going to throw those numbers on the number line. There's something special going on there. Now, x cannot be exactly those because those would make this whole thing equal to 0, not strictly less than 0. That's why I'm going to put some open circles instead of closed circles. See, if it was like less than or equal to, I would do a closed dot, but it's strictly less than, so I'll do some open dots. Right? Now, what do I shade? Is it the middle? Is it the tail ends? What are we shading? Right? Well, I can pick some test points. So let's pick the test point 10. What if at x equals 10? What would happen? Well, that'd be 10 plus 1, which is 11. 10 minus 3 is 7. Guys, is 77 less than 0?
67.
No. So that would be incorrect. How about 0? Guys, is 0 between negative 1 and 3? Let's try that. At x equals 0. So 0 plus 1 is 1. 0 minus 3 is negative 3. Guys, is negative 3 strictly less than 0?
Yeah.
Bing! Yes, it is. So this middle section you can shade. Okay. And then for completion, what if I do negative 10? At x equals negative 10. So that's negative 9 times negative 13, which is a positive value, which is not strictly less than 0. Right. So the only one that works is this middle section. That's going to shade that. Okay. Okay. So you know how to break up the number line and then test your intervals and then shade the correct answer? All right. So let's check here. I said the answer is C. Yeah, that's exactly what I just drew. C. Answer C. Okay. I I think if you change this inequality to greater than, then you'd be shading the tail ends instead of the middle section. Like that. All right. For a given mass, acceleration varies directly with net force. Suppose that for a given mass, we've got a force of 12 newtons results in an acceleration of 4 meters per second squared. What if we increase that force to 30 newtons, right? And I'll give you a hint at the end. Here's the actual proper formula. Your textbook and Alex had you setting up some with like constants or something, but I'll tell you F equals ma. So force equals mass times acceleration. So maybe I'll start from that. All right, force equals mass times acceleration. All right. Well,
Thought I had hate in one. Yeah, you might be special. You don't know the root, just a method? I mean, I figured it out as I.
oh, hey, pretty good. Somebody got it. So let's check this out. So I'm giving you the proper formula, force equals mass times acceleration. Even if you did not know that, you can still get the answer correct if you say, well, I know that there's some constant relationship between force and acceleration. It's a direct relationship. So if you have, if we make a little graph here, force versus acceleration, this would line up in a straight line. Right, and it turns out the slope is equal to the mass of the object. Right? But I can solve for whatever that constant is. Yes, it's the mass. So 12 equals m times 4. So m must be equal to 3. Right. The unit, by the way, turns out to be kilograms, but right, focused on the numbers here. Right. So now what we're going to do is we're going to take the same object, same mass. This goes right there. And I'm going to up the force all the way to 30 newtons. Guys, what is the resulting acceleration? 10. Yeah. And the unit happens to be meters per second squared. But yeah, the numerical value is 10. Right. You guys can do direct relationship? All right, let's get there. Let's get there.
I know my figures. I saw that.
All right, how about inverse relationship? We got pressures inversely related to the volume of a balloon. We start off with 1 atmosphere pressure with 600 cubic centimeters of volume. Now we're going to squeeze the volume down to a third of what it was before, 200 cubic centimeters. Okay. What's the resulting pressure? The ideal gas law is right there. That could be helpful. Okay. But it's an inverse relationship between pressure and volume. No. You still all right. All right. Yeah, so guys, the shortcut here is that if you have a third of the volume, you guys do see it's a third of the original volume, right? It turns out to be 3 times the pressure. Could you imagine that if you're squeezing down a balloon, the pressure inside the balloons get really, really big? So it's going to be 3 times, and 3 times 1 atmosphere is 3 atmospheres. Okay. Now, if you want to do the proper math, it looks like this. Now, here's the full ideal gas law formula, but really all you need is just this piece of it here. Pressure times volume turns out to be some constant. That signifies an inverse relationship between the pressure and the volume. Right? If they're multiplied together on one side, or if you divide 1 over it, so 1's proportional to 1 over the other. Right? Inverse relationship. Now, for 1 atmosphere and a volume of 600 cubic centimeters, the whole nRT, some constant comes out something, right? But since that's constant, that'll be true across scenarios. So now that 600 atmosphere cubic centimeters is going to apply to a new scenario. We're going to squeeze the balloon down to a third of its original volume, right? And that's going to set up a new pressure. So divide down the 200. I'm getting pressure 2 is 3, and then the unit that carries over is atmospheres, which was exactly what the correct answer was. 3 atmospheres. So inverse relationship. So inverse relationship, you can either do the variables multiplied together as some constant that makes the variables themselves inverse to each other, or you can do pressure equals K over V. Right. And here's another perspective that's really the same thing. Right? So P and V are still inversely related. Sorry, either way. All right, you guys get there. Get there. All right, well, what do we get to? Question 13? Yeah. All right, we are about out of time, so I'm gonna have to stop this right here. Stop this right here. Yeah. All right, well, whatever we didn't get to today, I'll shuffle those questions to the next one. Don't forget.